So that was humiliating. I just lost 40 minutes of recording because I forgot to mute, or rather unmute my microphone. Just goes to show that we're all capable of making really stupid mistakes. Please keep that in mind as you program. So, we have to write a bunch of methods here. Let's go ahead and start by writing our easiest of the 5 methods that I covered, which is size. Which all I have to do for that is public int size return size. That is our easiest method. We're not going to call it get size, even though it is a getter, because we don't really need to. Or rather, that's not what the convention is. We don't need to write a. We don't want any user to have access to the underlying list or the capacity. So we're not going to write anything that gets those. And we're also going to write, or we're going to start writing our toString method for testing purposes. Okay, toString. And that is just going to return arrays.toString, and that will be list. So that will just simply create a list representation of that. Let me go ahead and remove that. I've created a new class over here, which we'll use to test our program over here. So let's go ahead and just write a ArrayList of integers is equal list is equal to new myArrayList. Whoops. New myArrayList. And there we go. So we can go ahead and now print it out. Print out the list. And this should print out 10 nulls because we've just simply created a bunch of empty spaces, right? Now, obviously, when we finish our toString method, we don't want to be seeing all those nulls, but for right now, this is what we got. So let's go on and continue. Oops. Yeah, let's go ahead and switch to a more minimalistic view. View under full screen, enter distraction-free mode, because we don't really need anything else now. Okay. Now, let's go ahead and write ourselves our add method. Our add method will be written part by part as we make mistakes, or rather deliberate mistakes. So public, there were 2 add methods, public boolean add, which takes in a item, and that returns true or false. It should always return true, so that's what I'm going to put in. And then we will have a public void add and that takes in an index followed by an item. Okay, so that's what we've got. We've got our 2 add methods. Now we are going to be lazy. Since add adds an item to the end of a list, this is going to add it to the last known location, or to the last possible location. What we are going to do is that we are going to add that item. We're going to go ahead and just use this other add method. So we only have to write one. This.add size item. Now think about it. If the size is 0 and it's an empty list, then we're going to be adding that to index 0. If the list has 1 item in it, size 1, we're going to add this item to index 1, which doesn't exist yet, but it's perfectly fine to add an item so long at that out of bounds location, so long as it doesn't create a gap. That's the big thing. No gaps in this. So let's go ahead and so all the work is just going to go over here. This is just shorthand for this. Okay. First thing I'm going to do is do size ++ over here so that I don't forget it at the end. This will increment the size of the list. The next thing I'm going to do is that I'm going to make sure that int index is actually a valid location for me to use. Okay? So if index is less than 0, that's not a valid location. Or if the index is greater than size, right? Size is the last possible location I can add something. So if it's greater than that, that would create a gap. So that's not good. And so what I'm going to do over here is I'm going to deliberately crash the program if we try to add out of bounds. And the way you can deliberately crash a program is by throwing a new exception. We can throw a general exception like this, or we can throw and this actually is a type of exception that would have to be caught, but we have actually way more specific exceptions. That terminology, by the way, remember, it's a try-catch block because you're going to catch a thrown exception. So there's two types of exceptions. You have to have ones that are either handled or ones that you can just let fly. And so one of those that you don't have to handle is an index out of bounds exception. Handle meaning surround it with a try-catch block. Or use some other terminology, the throws keyword, but throws as opposed to throw. So we're going to use the index out of bounds exception, and here we can put in a more detailed message for our user, such as index plus index is out of bounds for size and then size. So we can go ahead and actually test this. So let's go over to this tester, right? And over here we can run this. And now if we try to do list.add and try to add it to add negative, let's see, add 100 to item to index -1. We run this. -1 doesn't work, and we're going to try to add it, of course, maybe to index 1. And that's not going to work because there's no items in there. And try to add it to index 0. That'll be perfectly fine, but of course it doesn't add anything in because I didn't put anything in there yet. So let's go back to my array list. So over here, let us continue. Not really sure why it's highlighting in red, but yep, uncheck cast, that's fine. So next thing we're going to do, well, let's go ahead and store that item at that location. That's all we need. So now if we run it, great, that seems to work. So let's go ahead and just now add 100. This would add 200, 300. Right, that actually seems to be working. That's pretty satisfying. But of course, the minute I try to do something like this, list.add 150. Whoops. Well, first off, I gotta put in a semicolon, otherwise I'm in big trouble. Semicolon here, run it again. Uh-oh, I overwrote the 200. What needs to happen? When I add an item over here, I need it so that the 200 gets pushed over by the 150. Right? The 200 should be pushed over by the 150. Right? I should move, the 300 should get over here, the 200 should be over here so that there's space for the 150 to go. Right? For an add, we are inserting something. Let's go back to this. All right, so how do I do that? Well, I've got to manually move those items over. What I'm going to do is a for loop, right? If I want to insert it into a specific index, like over here, then what I need to do is that I need to take all the items from the end and move them over 1. So like, say I wanted to put in 0. I'd have to, at the beginning, I'd have to take 300, move it over to here. Take 200, move it over to here. Take 100, move it over to here. And then I'd be free to put the 0 in. So this for loop will start at the end of the list. For int I is equal to, what is the end of the list? It's not here at the end. It's not the length of the array. Instead, it is size minus 1. That is the last index that physically has something in it. Then what are we going to do? Well, we got to go down. So what is our stopping point then? When do we want to stop? We can stop moving items over after we've moved over the item at the index we want to insert into. So while I is greater than or equal to index, well, it's greater than or equal to the index we are looking at inserting into, we need to keep moving stuff over. And that's fairly straightforward. We take the item. Suppose I'm currently at I. What do I need to do? If I'm currently at I need to take what I have and store it 1 to the right. So we take what's in I and store it 1 to the right. Let's go ahead and run this and see now what happens. Right? What this did was it started over here, it moved the 300 over, moved the 200 over, and then it overwrote the 150. Technically, we overwrote the null with 300, the 300 with 200, and then overwrote the 200 with 150. That's what we did. Okay, so now, great. Following me so far? If not, that's why it's a video. Go back and rewind. But all we did is that we start at this location. And we start at that location because it was the last possible thing, because we need to move over everything to the right of what we're inserting so that we can make space for that item. Okay. Now let's go back to our test. So now let's go ahead and write a more thorough test. For int I is equal to 0, I is less than 100. Let's go ahead and run this. Right. List.add index 0 I. So it's going to add 0 to 0, then it's going to add 1 to the front, then 2 to the front, then 3 to the front, and so on and so forth. So we run this. Ooh, exception. Deliberate exception on my part. Right? It says 10 is out of bounds for 10. So let's go ahead and print out the list every time we add something. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then finally when we try to add 10, what happened? Well, this filled up. This filled up. There's no room for anything anymore. So how do we solve that problem? Well, what we have to do here is we have to do the final part of the add method, which is that if the array gets too big, we need to cheat. And what we're going to do is we're going to make an array twice as big as the original, right? You cannot resize an array. So if I want to add another item over there, I've got only one option, which is to cheat, make an array that's twice as big as the old one, and copy it over. I'm not going to make it once because I don't want to make a new array that's 1 bigger. That would certainly work. But then I'd have to do this whole making a new array every single time I add a new item. If I multiply it, it's not going to, if I double the capacity, it's not going to happen too often. So we're going to do this fairly straight. It's actually going to not be too messy at all. If the size equals the capacity. In other words, if I have as many items in my list as I can currently hold, then what I'm going to do is I'm going to create a new method called Reallocate, assuming I can spell it. Okay? And what Reallocate is going to do is that it's a completely private method, right? It's just that we're just putting it in a method for organization purposes to make it easier. Private void reallocate. And what we do with reallocate is the first thing we do is we double our capacity. We say we want twice the capacity of what we want of what we currently have. Of course, that won't actually do anything by itself. The next thing we're going to do is we are going to make a new list. E new list is equal to new e, a new array of e's of the current capacity, which is twice what we previously had. And we need to do that whole, actually we can't make a new e, remember? So we have to do that whole casting thing. Right, just like we did in this line over here. Okay, and now that we've made a new array twice as large as the original, what we're going to do silently, so the user never really sees this, is that we're going to just simply take everything from the old list, list.length or size would both work. I'm going to just go ahead and use size because that's more exact. So everything in the old list and move it into the new one. So take what's in the old list and move it into the new one. And then remember over here, new list is a local variable. So if I just leave it like this, I'm not really doing anything. So that's no good. So what I'm going to do over here instead is that I'm going to say list is equal to new list. And what this is going to do is that this is going to take the memory location of new list and store it inside the list variable. So now the instance variable now points to that memory this new giant bigger block. And so now if we run this, let's go ahead and see. Now if we run this, what do we get? We get, notice how basically we add a bunch of items and now it doubles. Add a bunch of items and it fills up and then it doubles in capacity again and again and again. So that's all there is to the add method. I say all there is, that was a lot in almost 20 minutes. It's actually a good time for that. So, next one, we are going to actually fix our toString method because we don't want to see all these nulls actually if I'm a user, right? We shouldn't see the internals of how this works.